All right, this is pre-algebra lesson 10.5, surface area. So here's the deal. I'm only going to show you how to do one of these, and then I'm going to let you guys get started. Because it's real simple. On any of these three-dimensional figures, right, or space figures, I showed you yesterday how you make a net, right? A net is if you were to cut out the sides and just lay it out flat, what it would be. I'm going to show you a couple of things. Here we go. Here's what is this guy called? What is that? That's not a cube. Rectangular prism, right? And in order for you to tell me the surface area, what I'm asking for is, I'm asking for you to tell me how much wrapping paper it would take exactly in square inches or square feet or whatever to wrap this thing. In order to do that, you have to know what's the title of the lesson called? Surface area. So I need to know the area of the surface of the object, right? So it's very simple. How many sides does that guy have? It's a rectangular prism. How many sides does he have? He has 6, right? If you were to unwrap this thing, it would look like this, right? We did this yesterday, right? It would look like this. Agreed? Mm-hmm. That's what it would be. Or you could flip the sides up and then the top goes over. You got it. What you have to be able to do, though, is in order to do this, you need to know the dimensions of each one of these flat objects. Does that make sense? You got to know the dimensions of each one. That's where they will tell you that stuff by doing this. They'll go, okay, this is 6 inches, this is 8 inches, and this is 4 inches. And so when you lay this thing out, we're going to call this thing here. Let's just say that the red box that's the bottom. Do you agree what I'm saying? What's the dimensions? What does dimensions mean? When I say what's the dimensions of the bottom, what am I talking about?
Base and height.
Base and height. What is the dimensions of the bottom? 6 by 8. So then this right here is 6. Actually, it would be 6 inches by 8 inches. Does that make sense? That's the bottom. Which tells you that every one of these lines, that line, that line, that line, and that line, what is that? That line is always going to be 6 inches, right? You're looking at it, right? So you know that that's true. And that means that this line and this line and this line are all 8 inches, right? So you know this. So that means that you can do most of this. Now, if this guy right here is 4 inches, then which ones are 4 inches? That would be this short guy here, that short guy here, this short guy here, this short guy here, this guy here, this guy here. Does that make sense? They're all 4 inches. You just have to, each one of these, you have to figure out what is it.
Wouldn't it be the top box also?
Sure. Yeah. No, you're right. That's 4 inches, and that's where you just have to be able to, in your head, all of this has to happen. You have to be able to envision this thing coming up and this thing coming. You know what I'm saying? And then the top goes. So then you have to, on each one of these shapes, you have to be able to tell me the dimensions. If you know the dimensions, you're in good shape. Then you go, okay. So then this is what I do. You have to know how many sides there are, and then what you should do is lay them out. You should go, okay, bottom and top. You know what's going to be true about the bottom and the top?
Equal.
They're going to be identical, right? What's the dimensions of the bottom and the top? 6 by 8. So how many square inches is the bottom and the top? 48 inches squared, right? And that means that this is also 48 inches squared. We now have the front and the back, which should be identical, right? It's a rectangular prism. The front is this guy, right? So I'll do it in blue. The front is this thing, right? And the back, right? What's the dimensions of the front? Look at it. It would be 6 by 4. Do you see it? Because if this is 4, that means this is 4. So it would be 6 by 4. Does that make sense?
Yes.
6 by 4. So that means that the front, which is this guy, remember laying it out? That's the front. It's 6 by 4, which makes the front and the back 24 square inches. Does that make sense? Does that make sense? Okay. And then what's left then? Left and the right. Right, which should be identical. We'll do this one in orange. The left and the right are these guys here. Right? What is their dimensions?
4 by 8.
8 by 4, right? These are 8 by 4. So 8 times 4 is 32 squared inches. 32 squared inches. Is there any other sides to this figure? Is there any other piece of this figure that needs to be wrapped? No. So what do I do with this whole thing? I add them up. 48 plus 48 plus 24 plus 24 plus 32 plus 32. Get your calculator out, whatever that is. That's how many square inches it takes to wrap this whole box. Does that make sense? What does it come out to? Is that true? 208 squared inches. And what are we talking about here? That would be, what is 208? We're calling it the surface area. The area of the surface of the object. Does that make sense? Okay. What about, let me give you this one. Let me give you another object.
Are we doing this?
Nope. I'm showing you all these, and then you guys I'm just going to let you do them because, they take forever. No, I need to make it a little bit of a different angle. Okay. Okay, do you see it? What is that thing called? Triangular prism, right? Okay, a triangular prism. In order for me to do this, I have to do something. What do I need to do? What's it called? I need to draw a net, right? Does that make sense? So I'm going to do this for you. That is going to be, we'll say, 4 centimeters. And this is going to be 12 centimeters. Believe it or not, that's all you need to know for this whole thing. Those two things. Now, we're going to draw ourselves a net. I'll draw it in purple. The net is going to look do you agree? Yep. Look at it. You need to be able to wrap your brain around that. Does that look like it's going to make that is that object's net? Okay. We also know that. I'll put this here. We know that this right here is how long? That is 4 centimeters. And we know that this is 12 centimeters, which tells you that this line is 12. This line. What's the height of this triangle? 4. Does that make sense? Okay, you guys have all that. You understand that that's all you need is those two things. Oh, that's not true. I need one more thing.
You need the side.
I need this side over here. So this is going to be 3 centimeters.
Yeah, but doesn't the 12 fit into the side? So if you just divide
The 12 doesn't. The 12 has nothing to do with, it has the length of this. See that right there? That guy needs to be 3. Does that make sense? Okay. Which means that, like, this is 3, that is 3, that is 3. Does that make sense? Okay. So, how do we do this then? We need to lay it out. We've laid it out. We've laid out our net, and now we need to label them. So, in our object here, we need to label them. Well, how are we going to label them? What do you want to do? Let's call this one let's call this guy what do you want to call it? The front. I agree. We'll call this the front. What is the dimensions of the front? Not that. Dimensions is not how many square inches. The dimensions is what by what, right? So what's the dimensions of the front?
12 by 3.
It's 12 by 3. It's not 4, right? 4 is the height of this triangle. Does that make sense? 4 is the height. What's the length of this side here, right? There's do you agree it's just a rectangle?
Yeah.
Right? What is the length? What is the dimensions of the rectangle? Is 12 by 3, which is 36 squared centimeters. Right? Okay. What else are we going to call one? Let's do this one in burgundy. I think that's burgundy. Is it burgundy? What are we going to call that guy?
Back?
The back. We'll call that thing the back. Now listen, does it matter what you call it?
No.
No, it really doesn't. As long as you get it, you can call that one it would be tough to call it the top because then they would both, the front and the back would both be the top. But anyway, the back. Since it has the exact same dimensions as the front, what is it?
76 centimeters squared.
Right? And then what are we going to call this guy here in gold? What is this guy? We'll call him the bottom. And he is also 36 centimeters squared. Yes? And so now we have the left and the right, right? The left and the right are, what are they? They're triangles, right? And so we have to know the area of the of the triangles, what's the formula for finding the area of a triangle? Not pi r squared. What is the half of the base times the height, right? It's half of the base times the height. So then, what is the base times the height here? What is this triangle here? What is the dimensions? Well, what's the base?
3.
3. What's the height?
4.
4. Does that make sense? What is 3 times 4? What is 1/2 times 3 times 4? Should you go with what? Should you go 1/2 times 3? No, I wouldn't do that. I would go 1/2 times 4, which is 1/2 times 4 is
1/2 times 4.
2. 2 times 3 is 6, right? So that means that each of the triangles, we're going to go right, left, 6 centimeters squared, 6 centimeters squared. Is that all the sides?
Yes.
Yeah. So then what do? Add them up. What's it add up to?
You do that.
120. Oh my god.
Make sense? Does it make sense? Yeah.
But how would a 4 centimeter triangle fit in like a 3 centimeter?
No, listen, I'm confused. If it would have to, right? Obviously, the distance, here's my triangle, right? It's an equilateral triangle. Do you agree? Oh, I see. You're saying that this would be shorter than the sides. Yeah, whatever. Doesn't matter.
Would be 2.
Right. I don't care. I'm making up numbers. I'm making up numbers. I could have put 17.48. I could have put a billion. You're just following the rules, right? Just because I put it in wrong doesn't. I'm just making up numbers. Okay.
So we don't even have to say like, oh no, yes we do. I can say we don't.
Last one. Surface area of a cylinder. This is a weird one. Okay. I need you to understand a few things about this. Okay, cylinder. How many sides are there on a cylinder?
0.
There are,
Or 2. 2.
no, there are 3. There's the left, the right, and then which other side is there?
The surround
This side, right? I mean, like, so you have this, you need to all be able to wrap your brain around that. Do you all see that there are 3? Right? How many sides are there? I'm just curious. In a cone, there's only 2. There's the circle, and then there's the side, right? Does that make sense? You all get that? Okay. Anyway, in a circle, well, before I do this, let's lay out the map, or the net, right? You have the side, which is a circle. You have the side, which is a circle. And then you have, agreed, look at that. We've done this before. You all recognize a cylinder, right? Top, bottom, and then this side makes a perfect, this is a square? Rectangle, right? You agree? So, that is what the net would look like. So then what is the information that I need in order to find this? This is important. I need to know, what do I need to know to find the area of the circle? What do I need to know? What's the only thing I need to know?
Radius.
I need to know the radius, because what is the area of a circle?
Pi r squared.
Pi r squared. So we know what pi is, we don't know what r is, and we know how to square it. So we just need the radius. So if I gave you the radius and told you that the radius was, we'll say 3 inches, that's the radius, okay, that would give us, that is enough information to give us the area of the circles. Agreed? And they're going to be identical. I just need to find the circle once, then there's 2 of them. What about the rectangle? I need you to see this. Let's do it again. I really need you to see this. Look at it. This is important. Okay. Here's my cylinder. Do you agree that that's what this thing is? I'm just going to lay on its side, right? I mean, like here it is. Circle 3 inches, radius, 3-inch radius. Okay, this is the rectangle now, right? I unfold it just like I have on the screen. I've unfolded it. Okay, what is this right here? Remember, here it is. What is this distance? That would be this distance, right? So I need to tell you what that distance is. Do you agree with that? I need to tell you. Okay, so I'll tell you that is, we'll say that's 10 inches, a nice easy one. Okay, so the distance here, the height of this thing, right? So the height of this thing, the height is 10 inches. Does that make sense? Okay. But now look here. This is very important. Look here. What is the radius here of this circle? 3 inches. Do we agree? It's 3 inches? Okay, so hold on. What is this side then? Look at it. What is the side? No, it's not 6. What is that side? This is look at this. What object does this make up?
Circle.
A circle, right? What is the distance around a circle called?
Circumference.
The circumference. When I unfold it, what is this distance? It's the circumference of the circle. Does that make sense? The distance around the circle is the circumference, which means that when I unfold it all, this length is the circumference of the circle. So this right here is the circumference of the circle. What's the formula for finding the circumference of a circle again? Do you remember?
Pi times diameter.
Diameter times pi, right? So then, if you have the radius, can you tell me what the diameter is?
Yes.
How do you do that? How do you tell me what the diameter is?
Radius.
It's what? Times 2. Whatever the radius is, you multiply by 2. Right? That gives you the diameter, and then you multiply that by pi, and that gives you the circumference, which gives you this length. And we already know that this is 10 inches. This is the circumference, right? And this, well, anyway, I'll do it for you. Just this once, and then I'm going to make you guys do it. Okay. So this is 10 inches. So you're watching. I'm going to do it for you once, and then I'm going to let you guys get started on your homework. So we have the left and the right, which are going to be identical. Those are circles with a 3-inch radius. So the area of that circle is pi r squared. We've done that. Area equals 3.14 times the radius, which is 3 squared. 3 squared is 9. 9 times 3.14. What's 9 times 3.14?
28.26.
28.26 squared inches. Yes? Agreed?
Yeah. And also.
And then the same thing with the right. 28.26 squared inches.
So we don't have to.
We also have now the one side. Does that make sense? All right. How do listen, I need to know the dimensions of the side, which is a rectangle. What is this distance right here? Gigi, what's that distance? 10, right? It's right here, right? When we unfolded it, that thing's 10. Good. So then this is 10 inches. And Gigi, that side, what is that side going to be? We did this. What is it going to be? How do I figure out how long that side is? Right, which is called the circumference. We're going to find the circumference of the circle, and the circumference of the circle is that side, right? So what is the circumference? It is diameter times pi, right? Circumference equals diameter times pi, which is circumference equals, what's the diameter, Gigi?
6.
Good, 6. The radius is 3, diameter is 6 times, 6 times 3.14. What is 6 times? 18.84. So this is 18.84, right? Inches. How do I find the area of the rectangle then, Gigi?
18.84 times 10.
Booyah. Whenever you multiply something by 10, what's the only thing you have to do?
Add a 0.
Not true. That is absolutely a lie. You do not add a 0. What's the only thing you have to do? Move the decimal, right? Adding a 0 here would make this 18.840, which didn't do jack. Oh, didn't do jack. That's funny, right? Jack. Anyway, 18.84 times 10 is 188.4. So this guy here is 188.4 squared inches. What do I do now? Add them up. Ooh, this is a weird one. What is 28.26 plus 28.26 plus 188.4? What is it?
Oh, weird.
244 point what?
92.
Surface area. Notice I call it surface area. It's the area of the surface. Does that make sense? In the end, you all have the tools to do this. It just does take time. There's many steps. You have to lay it out. There's, I don't give you a ton of these because each one there's several problems. 244.92. Nope. Unless they tell you to. If they say to, then you do it. Whatever. Okay. Let me give you. There's no. There it is. Okay. Let me give you your homework. Let me see how many I give you. I hope it's a lot. I hope it's a lot. The surface area of prisms and cylinders. It is page 548, 1 through 12 even. That's 6 questions. Hold on, and, sorry, got to do it, and number 10. I have to give you one that has a, oh wait, I did already, never mind. 1 through 12 even, perfect. No, we're good. In fact, you know what? I'll do this for you. I'll make it 1 through 10 even. There you go.